Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method. So we are going to solve the given differential equation using variation of parameters method in three ways. Okay, we'll begin with part 1. So let's get going. Problem solve. D square minus 3d plus 2 into y equal to sine e power minus x, or y double dash minus 3y dash plus 2y equal to sine e power minus x using variation of parameters method. Solution. So the first equation is an operator form of this equation. Okay, both equations are same. So I'll take the given differential equation as the second one. And also we are given a differential equation of order 2. Given differential equation y double dash minus 3y dash plus 2y equal to sine of e power minus x. Consider it as equation number 1. And we can write y double dash, y double dash or y2 is nothing but d square y by dx square. Whereas y dash or y1 is nothing but dy by dx. Okay, we can write this equation as d square y by dx square minus 3 into dy by dx plus 2y equal to sine e power minus x. Again we can write d square y by dx square as capital D square y, since d is an operator, differential operator, right? D is a differential operator, so we can write d square y by dx square as d square y minus 3 dy plus 2y equal to sine of e power minus x. Now take y common from all the three terms of LHS. We'll get d square minus 3d plus 2 into y equal to sine e power minus x. Consider it as equation number 2, right? Which is in operator form. Say f of d into y equal to some function of x, where f of d equal to d square minus 3d plus 2. Okay, let's now write the homogeneous equation of equation 2. The homogeneous equation of 2 is d square minus 3d plus 2 into y will be 0. Consider it as equation 3. Now we'll find the solution of equation 3, and using that solution we'll find the general solution of equation 1 or equation 2 or equation 1 and 2, right? So we'll find the solution of equation 3 using auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square minus 3d plus 2, right? Let's replace differential operator d by m, so that we'll get f of m equal to m square minus 3m plus 2. Then the auxiliary equation becomes m square minus 3m plus 2 equals to 0. Now we need to find roots to this equation. Just write minus 3m as minus 2m minus m plus 2 equals to 0. Now take m common from the first two terms, we'll get m times m minus 2, and take minus common from the next two terms, we'll get minus of m minus 2 equals to 0. Now we can take m minus 2 common from these two terms because it exists in two terms. Let's take m minus 2 common, then we'll get m minus 2 into m minus 1 equals to 0. Now we equate each factor to 0. From m minus 2 equals to 0, we'll get m equals to 2, and from m minus 1 equals to 1, we'll get m equal to 1, right? From this, we'll get m equal to 2, 1, or m equal to 1, 2. The roots are real and distinct. We know that when two roots, say m1 and m2, are real and distinct, then the solution of homogeneous equation looks like one constant into e power 1 root into x plus another constant into e power another root into x. So here I am taking C3, C4 instead of C1 and C2 because I wanted C1 and C2 to appear in the last general solution of the given differential equation, right? Let's now write the solution of our homogeneous equation. The solution to the homogeneous equation is given by y equal to one constant into e power 1 root into x plus another constant into e power another root into x. We'll get y equal to c3 e power x plus c4 e power 2x, which is the solution of the given the general solution of equation 1 and equation 2. Let y equal to, just replace the constants or parameters with functions of x, a and b. We'll get y equal to a e power x plus b e power 2x be the general solution of one and 2. Okay, where a and b are functions of x. We are saying y equal to a e power x plus b e power 2x is the solution, general solution of 1 and 2, which is nothing but y equal to a e power x plus b e power 2x is the solution of 1 and 2, right? So it will satisfy equation 1 and 2 as well, right? Since y satisfies equation 2, so we can substitute y in equation 1, right? But here we have y dash also. So let's find y dash and y double dash and substitute in equation 1. We have y equal to a e power x plus b e power 2x, right? We need to find y dash here, which is equals to a e power x whole dash plus b e power 2x whole dash, right? From this we'll get y dash equals to, here we need to apply uv whole dash formula, which is equals to u dash v plus v dash u. We'll get a dash e power x plus a into e power x whole dash plus b dash e power 2x plus b into e power 2x whole dash. This gives us a dash e power x plus a into e power x whole dash is e power x plus b dash e power 2x plus b into e power 2x whole dash is 2 e power 2x. This gives us a dash e power x plus a e power x plus b dash e power 2x plus 2b e power 2x. Let's now write the terms involving a dash and b dash firstly. We'll get a dash e power x plus b dash e power 2x. Now write the terms involving a and b. We'll get a e power x plus 2b e power 2x. Let a dash e power x plus b dash e power 2x 0. Consider it as equation number 4. So that while finding y double dash, a double dash and b double dash will not appear. Okay, then this becomes y dash equals to 0 plus a power x plus 2b e power 2x. From this we'll get y dash equals to a e power x plus 2b e power 2x. So we got y dash. Let's now find y double dash. And this equation 4, we'll use this equation 4 to find a dash and b dash. Okay. We have y dash equals to a e power x plus 2b e power 2x, right? Let's now find y double dash. Y double dash equals to a e power x whole dash plus 2 into b e power 2x whole dash. Here also we need to apply uv whole dash formula, which is equals to u dash v plus v dash u. We'll get a dash e power x plus a into e power x whole dash plus 2 times b dash e power 2x plus b into e power 2x whole dash. This gives us a dash e power x plus a into e power x whole dash is derivative of e with respect to x, which is e power x, plus 2 times b dash e power 2x plus b into derivative of e power 2x with respect to x is 2 e power 2x. This gives us a dash e power x plus a e power x plus 2 times b dash e power 2x plus 2b e power 2x, right? We'll get y dash equals to a dash e power x plus a e power x plus 2b dash e power 2x plus 2 to the 4 b e power 2x, right? So we got y double dash, which is equals to a dash e power x plus 2b dash e power 2x plus a e power x plus 4b e power 2x. I just wrote the terms involving a dash and b dash firstly, and later I wrote the terms involving a and b, right? Now we got y dash and y double dash, right? So let's substitute y double dash and y dash in equation 1. Since y is the solution of equation 1, so it will satisfy equation 1 for that purpose. So that we'll substitute y dash and y double dash in equation 1, right? Let's substitute. We have equation 1, y double dash minus 3y dash plus 2y equal to sine e power minus x. Okay, now let's substitute y dash and y double dash in 1. We get y dash a dash e power x plus 2b dash e power 2x plus a e power x plus 4b e power 2x minus 3 into y dash a e power x plus 2b e power 2x plus 2 into y a e power x plus b e power 2x equal to sine e power minus x. This gives us a dash e power x plus 2b dash e power 2x plus a power x plus 4b e power 2x minus 3a e power x minus into plus minus 3 to the 6 b e power 2x plus 2a e power x plus 2b e power 2x equal to sine e power minus x, right? Here, okay, write the first two terms as it is. A e power x plus 2a e power x is plus 3a e power x, right, minus 3a e power x. We just wrote the terms involving a e power x. Okay, now 4b e power 2x plus 2b e power 2x gives 6b e power 2x minus 6b e power 2x. Terms involving b e power 2x equals to sine of e power minus x. So here plus 3a e power x minus 3a e power x gets cancelled. Likewise 6b e power minus 2x and minus 6b e power 2x gets cancelled. Then we'll get a dash e power x plus 2b dash e power 2x equal to sine of e power minus x. We can consider it as some equation 5. We have equation 4 and 5, which involves a dash and b dash, right? By solving equation 4 and 5, we'll get a dash and b dash. So let's solve 4 and 5. We have Equation 4, a dash e power x plus b dash e power 2x equals to 0. Equation 5, a dash e power x plus 2b dash e power 2x equals to sine of e power minus x, which is equation number 5. Now we'll solve equation 4 and 5. Solving 4 and 5. Change the signs. Here plus a dash e power x and minus a dash e power x get cancelled and we'll get minus 2b dash e power 2x plus b dash e power 2x gives minus b dash e power 2x equals to minus sine e power minus x, right? We'll get b dash e power 2x equals to sine of e power minus x. From this we'll get b dash equals to sine of e power minus x by e power 2x. So we got b dash equals to sine e power minus x by e power 2x, or we can write it as b dash equals to 1 by e power 2x into sine of e power minus x. We know that reciprocal of e power minus 2x is e power minus 2x. We'll get e power minus 2x into sine of e power minus x. Therefore, b dash equals to e power minus 2x into sine of e power minus x, right? We got b dash. Now we can substitute this b dash in equation 4 to find a dash. We have equation 4, this a dash e power x plus b dash e power 2x equals to 0. Now let's take the second term to RHS, then we'll get a dash e power x equals to minus b dash e power 2x. Now let's replace b dash with e power minus 2x sine e power minus x into e power 2x, right? This gives us minus e power 2x into e power 2x sine of e power x, right? E power minus 2x into e power 2x is e power minus 2x plus 2x, which is equals to e power 0, since e power 0 is 1. So you can replace this with e1, or we have not changed e1 1 by e power 2x as e power minus 2x. We can just directly cancel e power 2x. Okay, here you will get 1 by 2x. Or you can write this e power minus 2x as 1 by e power 2x into e power 2x, where e power 2x gets cancelled, you will get 1. You can just replace it with 1. You will get minus 1 into sine of e power minus x, which is equals to minus sine e power minus x. Okay, from this we'll get a dash equals to minus sine of e power minus x by e power x. Again, you can split this as minus 1 by e power x into sine of e power minus x, which is equals to minus 1 by our reciprocal of e power x is e power minus x. So you'll get minus e power minus x into sine of e power minus x, which is our a dash. Okay. Therefore, a dash equals to minus e power minus x into sine of e power minus x. See, we got a dash and b dash. Let's now find a, b using a dash and b dash. We have a dash equals to minus e power minus x sine of e power minus x, right? We can write a dash as derivative of a with respect to x equals to minus e power minus x sine of e power minus x. Now take the differential dx to RHS, then we'll get dA equal to minus e power minus x into sine of e power minus x into dx. Here the variables are separable. So we can perform integration. We'll get integral dA equal to minus integral minus e power minus x into sine of e power minus x into dx. Right? Let e power minus x equals to some t. Okay. Now differentiate on both sides with respect to x. Then we'll get derivative of e power minus x with respect to x is minus e power minus x equals to dt by dx. Now bring this differential dx to LHS, we'll get minus e power minus x into dx equals to dt. Or you can replace e power minus x dx by minus dt also, right? This gives us, we can just write this as sine of e power minus x into minus e power minus x into dx. Okay, and this will be easy to, more convenient to replace e power minus x with t and minus e power minus x into dx with dt. This gives us integral dA equal to, just replace e power minus x with t and minus e power minus x dx with dt. Then we'll get sine t into, we'll replace minus e power minus x into dx by dt. Okay. Since we know that integral dA is a, this is equals to integral sine t dt is minus cos t plus some integral constant, say c1. Now replace t. Since t equal to e power minus x, then we'll get a equal to minus cos of e power minus x plus c1. Therefore, a equal to minus cos of e power minus x plus c1. We got A. Let's now find B using B dash. We have B dash equals to e power minus 2x into sine of e power minus x, right? We can write B dash as dB by dx, that is derivative of b with respect to x, equal to e power minus 2x into sine of e power minus x. Now take the differential dx to RHS, then we'll get dB equal to e power minus 2x sine of e power minus x into dx, right? Here the variables are separable. So we can perform integration. We'll get integral dB equal to integral e power minus 2x into sine of e power minus x dx. Let e power minus x equals to some m. Okay, say m or u or p, whatever, or you can take it as some q, better. Now differentiate on both sides with respect to x. We'll get derivative of e power x with respect to x is minus e power minus x equal to dq by dx. From this we'll get minus e power minus x into dx equals to dq, or e power minus x dx equals to minus dq, right? In order to replace e power minus x by q, we'll just split e power minus 2x as e power minus x into e power minus x for our convenience. And we can write it as e power minus x into sine of e power minus x into e power minus x into dx, so that we can replace e power minus x into dx by minus dq, right? Then this becomes integral dB equal to integral e power minus x, replace e power minus x with q, we'll get q into sine q into replace e power minus x dx with minus dq, right? This gives us integral dB equal to minus integral q sine q dq. Let's now evaluate this integral. Let's now evaluate integral q sine q dq. Here the integrand is of the form product of polynomial function into trigonometric function. Let's consider the polynomial function as u and remaining part as dv and apply integral u dv, integration by parts formula. Integral u dv equals to uv minus integral v du. Here u is q and dv is sine q dq. Now differentiate on both sides with respect to q. We'll get dq, du by dq equal to derivative of q with respect to q is 1. From this we'll get du equal to dq, right? And here integrate on both sides. We'll get v equal to integral sine q dq is minus cos q. Now apply in this formula, then we'll get integral u, which is q, into dv. dv is sine q dq equal to uv, q into v minus cos q minus integral of v minus cos q into du. du is dq. This is equals to minus q cos q, minus into minus plus integral cos q dq. This gives us minus q cos q plus integral cos q dq is sine q, right? Since integral q sine q dq equal to minus q cos q plus sine q, then this becomes integral dv b equal to minus of integral q sine q dq is minus q cos q plus sine q plus integral constant say c2. This gives us minus into minus plus q cos q minus sine q plus c2, right? Now replace q by e power minus x. Then we'll get e power minus x cos e power minus x minus sine e power minus x plus c2, since q equal to e power minus x. Therefore b equal to e power minus x into cos of e power minus x minus sine of e power minus x plus c2, right? So we got a and b. Let's now write the general solution using y equal to a e power x plus b e power 2x. Just substitute a, b in this equation. Therefore, the general solution of 1 and 2 is given by y equal to a e power x plus b e power 2x. This is equals to a minus cos of e power minus x plus c1 into e power x plus b e power minus x cos of e power minus x minus sine of e power minus x plus c2 into e power 2x. This gives us minus e power x cos of e power minus x plus c1 e power x plus e power 2x into e power minus x cos of e power minus x minus e power 2x into sine of e power minus x plus c2 e power 2x. This gives us minus e power x cos of e power minus x plus c1 e power x plus e power 2x into e power minus x gives e power 2x minus x, which is e power x, right? We can replace it with e power x into cos of e power minus x minus e power 2x into sine of e power minus x plus c2 e power 2x. So here minus e power x cos e power minus x and plus e power x cos e power minus x gets cancelled, and we'll get c1 e power x minus e power 2x sine of e power minus x plus c2 e power 2x. This gives us, or we can write it as c1 e power x plus c2 e power 2x minus e power 2x into sine of e power minus x, which is the required solution. Therefore, y equal to c1 e power x plus c2 e power 2x minus e power 2x into sine of e power minus x is the required solution. So we have seen one way of solving the given differential equation using variation of parameters method in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.